Alrighty, Android developers, this Oracle Mobile Cloud Service episode is for you. We're going to show you with the Android SDK how to work with the MCS Data Offline and Sync API. I'm Chris Murett from the Oracle Mobile Platform team. Okay, you'll remember from a previous episode, we noted that the data offline and sync capabilities requires components on both the mobile client and the server side of Oracle Mobile Cloud Service. In considering the mobile client, we mentioned the broad steps to configuring the mobile client, which includes installing the MCS Android SDK, also covered in an earlier episode. And then from there, when working on custom APIs in MCS, we define the sync policies and write the actual client native code to use the data offline and sync functionality. The sync policies and this native code is the focus of this specific episode. Okay, for teaching purposes, let's say we're going to build a mobile app for couriers on their bicycles that lists the deliveries they need to make to different businesses. Now, you can appreciate, as couriers are always on the road, constantly with intermittent connectivity to their phones, the data offline and sync API is an ideal use case for them. So, in order to support this scenario, what we're going to do on the MCS server side is we're going to build a custom API that at the top level has a collection endpoint that returns delivery dockets for the courier, and then individual endpoints to get, post, put, and delete the individual delivery dockets back to the mobile device. So, with this custom API in mind for sync, we then need to define our sync policies on the mobile device. So let's first look at how we define these in our Android application. So in our Android app, we locate the MCS Oracle Mobile Cloud Config XML file we included as part of the SDK. Now here we can see we've set the SDK to work with a predefined MCS mobile backend called Courier MBE. Within the mobile backend block, to set the sync policies for custom APIs exposed through this mobile backend, we include a synchronization element and its children. The sync options are split into three sections: global policy settings, one or more individual policy sets for specific APIs we list, and a default policy block. So for the mobile custom courier path, which relates to our MCS server-side custom API for our application, we can see that we've defined sync policies: fetch from service on cached miss or expiry, expire after 180 seconds, and queue if offline. When listing policies for individual APIs, note the path string used here: mobile, custom courier, then $. The path parameter takes static paths or wildcarded paths, indicated by the stars you can see here. If we set the path to /mobile/custom/courier without any stars as wildcards, this means the relating policy will apply to a custom API that starts with mobile custom courier, but nothing else, such as mobile custom deliveries, or even a sub-resource such as mobile custom courier deliveries. Alternatively, if we use the same path but append 1 star as a wildcard, this will match any resource at the same level and +1, such as courier deliveries. Finally, if we use a double star for the path, this will match any resource at the same level and any nested resource to any depth. Now, you are free to define other sync policies for other APIs, or as we can see here, define a blanket default policy block and options that will apply to any other APIs you attempt to access via the data offline and sync APIs, but haven't defined a policy set previously for. Okay, so with the sync policies out of the way, let's now investigate the Android code needed to work with the data offline and sync functionality in the SDK. Okay, before working with the sync code, we need to log in anonymously to MCS or authenticate the user. Now, in this very simple application, I've set up a simple activity with a button to do this for us. Behind the button, we can see I get a handle on the mobile backend, then the authorization class, and finally log in anonymously for this simple demo. If we run this in the emulator, upon a successful anonymous login, the app then moves to a new activity, where we're going to do the actual data offline and sync code. So on the next page, we've set up a very simple activity with a list view. Now our goal is to fetch the deliveries from the remote custom API and display their title in cells of this list. Okay, so let's open the list activities Java file. Within the activities onCreate method, this is where the real magic will occur. To work with the sync classes, the first thing we need to do is get a handle on the mobile backend objects and synchronization objects provided by the MCS SDK. For development purposes, it's handy to purge the cache with a call to synchronization.purge when we start, though we would want to remove this code for production, otherwise nothing will ever be cached between restarts. From the synchronization object, we call the openEndpoint method to map to our remote MCS custom API, Courier API, which we also defined in our sync policies file, and the specific endpoint resource deliveries we want to access. The last parameter, mobile object class, defines the object types we will receive from the remote call in a moment. To act upon the remote endpoint, we use one of a set of builder classes provided by the SDK. Which builder class we choose depends on what the remote endpoint exposes. You might remember we said in the previous episode covering the server-side custom APIs for data offline and sync that these can return, for example, objects or collections. So for an object, we would use the SDK fetch object builder class. But in this case, for the Courier Deliveries API, as it is returning a collection of delivery dockets, we instead work with the fetch collection builder class. With a handle on the builder collection class from the endpoint, we can do things like set the URI parameters for the remote call via the withQuery parameter method. Though in this case, our remote API doesn't have any URI parameters, so I'll leave this commented out. Finally, we can call the builder execute method. This method is what actually fetches the data from the remote service and has a mobile endpoint callback when a response is received. When the callback is called, the onComplete method will be executed, which will contain any exception if there was an error, or the return collection of objects as an instance of mobile object collection for us to use. Within the onComplete method, we need to detect and handle any exception, or if null, work with the return collection from MCS. So as we can see here, I'm calling the getObjectList method, then its size method, logging the collection size. We can also retrieve individual objects. So in this very trivial example, we can see extracting the object list from the collection, then the 0 element of the collection. Then I'm assuming the object is a JSON object by calling getJSONObject and extracting a JSON property title. Now, this is all good and well, but this is a trivial example, you agree. We really want to populate the list view. So in Android, we do that with an adapter. Now, the following code is just an indicative example of how to do this, and I'll happily admit to any Android programmer there are probably better ways to do this, but this is a teaching example to give the general idea. So in order to update the list view, I'll create a method called updateList. What this does is grab the object list from the mobile object collection returned from MCS. Then, in a loop, it retrieves each JSON's object title property and assigns it to a simple string array list. If the array list is not empty, we then convert that to a string array, pass that to an array adapter, and give that to the list view to work with. As we can't update the user interface from a callback, which the update list has been called from, we have to execute the update with a call to run on UI thread. Great. So this is a good point to run this and look at the output. In running the app, we can see the delivery titles that are returned from MCS, which in themselves, I guess, isn't that interesting. However, if we switch to the logs, we can see the fetch of the Courier mobile backend and initialization of the sync engine, the setup of the cache database, and the purge call. Next, we can see the actual fetch, or more correctly, the get against our Courier Deliveries custom API in MCS. From there, we can see the request going out and the 200 response returned, and finally the number of objects returned in the collection. Next, our updateList method is called to take the collection and display the values in the list view we can see in the emulator. However, if we sit here and watch logs for some time, we can also see a periodic set of logs like this. This is the sync periodic refresh mechanism firing. If you remember, we configured periodic refresh in the Oracle Mobile Cloud config XML file to fire every 30 seconds. So literally, if we sit here, we see that fire again and again. And in addition, as we set the eviction period to 180 seconds, we will see the records evicted and new objects fetched from MCS eventually. However, when this happens, the screen doesn't automatically receive an event to refresh itself, and the data is shown in the list view. We need to provide a mechanism to do this. So how we'll achieve this here is by creating a timer, which in the onCreate method we'll configure to fire every 110 seconds. This will call a timer task and its associated run method. Now, in order to get the updated objects in the collection, we must call the mobile object collection reload resource method. Within the callback onComplete method, the mobile resource object has a handle on the updated collection. Once we have this, from here we just want to update the list view like we did previously, so we can make use of our update list method again. Right, so beyond setting up the sync policies file and doing the initial fetch of the data in a couple of lines of code, adding some code to retrieve the actual value we want to show in the cell, and some code to remind the list view to update itself periodically, think about here all the code that we didn't write. No code to set up and manage the local database on the device. No raw HTTP calls and dealing with stale data and flushing data and reloading the data. No threading code to fire off the periodic refresh. There is literally hundreds, if not thousands of lines of code taken care of for us here. So we can focus on building a compelling app over worrying about what is essentially plumbing, and a very complex plumbing problem at that. Thanks for joining us in this video. Hope to catch you in the next video soon.